Hi everyone, my name is Yu Chen Lee. You can also call me Jason. Today I'm talking about my dissertation proposal, information recovery in online social networks, identification and localization. Among the huge data among online social network, for example, Facebook, Twitter, Quora, the missing attributes are a common problem. So the first observation is that how do we label these missing attributes? And in this way, we can make the data quantity even more complete and bigger. So the second observation is that even with the same labeling, there's exists difference of a uh, degree of tendency. So how do we differentiate items with distinct properties? This will highly improve the data quality. Yeah. So for the introduction part, Facebook for the Facebook public pages, for example, like this figure, it's what Golden State Warriors Facebook public page. These public pages are public profile used by local business, companies, organization, or public figures like um, politicians, musicians, etc. The page hosts, um, they can decide which pages they want to promote. Yeah. So, for example, Golden State Warriors, it like Sport Illustrated, Oakland Museum, and also Giving Tuesday. This liking relation forms a public page graph. In each page, the information includes page ID, name, category, like sports team, country, fan count, and description. So in my proposal, among the various attribute information for data made available to us, location attributes are of particular interest to social scientists, since these digital footprints give social scientists insight into users' physical footprints outside of the online social network. So I try to approach and explore these research questions. First, how to identify missing nationality info of pages. Second, what challenges will we face when the identification becomes fine grained? And also, how can we identify subdivision, for example, state, labeling of pages? Last, how do we differentiate local pages from global pages? There are some related work. Um, First, Facebook user graph profiling. Uganda, they they do this profiling in 2011. Um, they analyze the Facebook user friendship graph, and by characterizing its global structure and related network properties. Yeah. Second, Facebook user analysis. Um, Dr. Barnett in 2017, they examined um, international relation among countries by building connections from co-occurrence of country keywords in Facebook user posts. One used the linguistic inquiry and keywords count to show that each public page has its own characteristics. Also, framing phenomenon exists in especially in political and news pages. However, these previous works do not leverage the relationship among public page to analyze cross-page user analysis. Another another trend of the related work is mainstream is inferring Twitter user location by leveraging the tweet text information. There are primary three primary research directions in this field. First, content-based keyword analysis takes advantage of text message related to a strong local geoscope, like for example at somewhere, at Sacramento, at Davis. Another huge chunk of another big part of the related work is in using the social ties. For example, like a friendship relationship between users. Yeah. Last part is, and also the latest one is using the cluster analysis to get decent results in various region granularities. They compare the results of geometric mean, k-means clustering, dbScan, and Gaussian mixture models. After introduction, I would then talk about the identification of pages nationality, then talk about how we do profiling based on the whole public page graph, and also the subregion identification of pages. And then we talk about how do we detect global pages, and last, my future work. So the question is, why are these nationality information missing? Because for a page hosts can choose to cover or uncover geographic location of a page. So in our data, there are 8 million, around 49.76% out of 60 million pages. They show their country information. Thus, we propose an efficient algorithm to identify country information. Since majority of public pages are commercial in oriented, so they tend to use more accurate location data. So this is very different from the user part, because users, they can like fake their location data because they don't have the they don't have the in they don't have these kind of factors to excellent to provide accurate data. So for this reason, we can use direct collection to get the golden location data on Facebook by directly using the location data on the page location attribute. For the data collection part, we use Facebook Graph API version 2.8 to collect our data. And we use a strategy of snowball sampling, starting from a set of popular public page seeds. Then we crawl by the crawl list, and each time we expand by adding into this list on pages which are liked by listed pages. First, we use majority vote algorithm to identify pages nationality. The vertices are in this graph. The vertices are known country and unknown country pages. The edges are like connections, and we take it as undirected. The observation is that most neighbors come from the same country. In a concept, we use majority vote by neighbor's nationality. The implementation, we use a priority queue sorted by the number of known country neighbors. So the time is E plus V log V, and the space is E plus V. For the performance evaluation, the accuracy part, we got 90.25% with 50% unknown country pages. This distribution is the same as the data we crawl, so we simulate this in the golden data. The F1 score is 0.904, which is quite high. This is computed from the Precision and Recode. The processing order is by number of known country neighbors. This accuracy remains over 90%, while a page has at least 30 known country neighbors. For the robustness part, we test this robustness by changing the unknown country page ratio among all pages. As we can see that when the unknown page ratio is less than 60%, our accuracy is still over 90%, and the standard deviation is smaller than 0.15%. The next part, I would talk about profiling of Facebook public page graph based on the identification of page's nationality. First, I would talk about page distribution, then talk about connectivity, and then the last part is the country's international impact. There are three parts. One is social influence, and second is the correlation. The last part is the clustering. The page distribution, we first look at it from the country's perspective. There are 60 million pages, and 41% are US pages. Second highest is the orange part is UK, United Kingdom, 5.5%. This imbalance reflects Pareto principle. The top 10 countries occupy nearly 70% pages. And if we see the page distribution by category, there are actually in Facebook there are over 1,000 categories in total. But again, the Pareto principle shows again that only top 100 categories cover 91.5%. Thus, we classify this top 100 into 7 broader categories. These 7 categories are brands and products, people, companies and organizations, websites and blogs, entertainment, local business and places. So we can see that the sum of companies and organizations and local business and places accounts for over 60% of all pages. In a below figure, we sort all country pages by a number of company in descending orders. So we can see that in this figure, company, organization, and local business places are major parts in most countries, and they occupy almost the same proportion, almost similar proportion. So again, this supports the argument that most public pages on Facebook are commercial promotion oriented. For connectivity, in average, there are for each page the degree, age degree is 62, median is 17. So 77.5% are domestic ages, means these ages are among the pages in the same country. We run breadth search from the highest degree page in each country. Nearly all countries are closely connected, within 5% in breadth search. So we can see that the yellow is 5%, and we can see most are the green dots, green grids. So in this heat map, we can see most are within 5%. For the international graph, we define the international graph as a vertex, international vertex, and also the international age. The international vertex are aggregated by public pages whose nationality are the same country. The international age are a set of directed ages denoting that source nations like destination nations, and these are between different countries. To address the country's international impact, we use two measures. PageRank and Between centrality. So in following, we would first introduce PageRank and Between centrality. PageRank analyzes relative importance of a vertex in a graph by calculating the probability that a vertex will be reached when starting from a random vertex. So this algorithm first assign an initial probability value to each vertex. For example, we want to view an ordered vertex representing all countries. LV. So there are two parts. One is 1 minus d. One is d. It's a damping vector for continual traversal, and n is the total number of vertices. So first part is the average probability 1 over n. The other part is constituted by the BVI, the set of vertex which like VI, the VJ, and it's PVJ over LVJ. LVJ is the number of likes from vertex VJ. So it keeps iterative updates probability value of each vertex. Second, Bernoulli centrality. For Bernoulli centrality, it finds information hubs in a network graph. So it measures by the number of shortest paths which pass through the vertex. Higher Bernoulli centrality means that more information will pass through that vertex by connection of edges. On the other hand, if we remove the vertex, the higher the Bernoulli centrality, the higher potential to disconnect the graph. So there are 242 vertices countries in international graph. This table shows the union of the top 10 countries in a PageRank and also Bernoulli centrality, and we order it by the PageRank. There are columns of number of pages, number of nations connected. Number of nations connected represents the average number of in-degree and out-degree edges which connect two nations. The last column is the Bernoulli rank, Bernoulli centrality rank. Not surprisingly, we can see that the two largest countries, United States and United Kingdom, they have a great influence quantified both by PageRank and Bernoulli centrality. However, the interesting part is that New Zealand and Switzerland, their page number are just 86,000 and 30,000, which is quite small compared to the other top 10 nations. So this implies that New Zealand and Switzerland, they use Facebook public page efficiently to connect with other pages internationally, which would benefit promoting their own nations and interacting with other nations. So in a summary for the table, we can see that 8 countries overlap in the top 10 list of both PageRank and Bernoulli centrality. In this table, what we do not consider underestimate is due to the low involvement in Facebook. As we can see in the right figure, there are mostly the blue parts means Facebook, but there are 2 parts. One is the red part for China and the orange part for Russia. For example, China authority forbids Facebook, and most Chinese people use Weixin, WeChat or QQ instead. So the other part is Vkontakte, VK, is much more popular in Russia. So these 2 nations, we have underestimation due to a low involvement in Facebook. So next, we would like to talk about country international impact from a correlation aspect. The Kendall's rank correlation coefficient is used to examine correlation among attributes. These ranking lists of attributes are compared in order to examine the correlation among attributes of vertex in international graph. So there are mainly two components, NC and ND. NC represent concordant pairs, which means if xi smaller than yi, then xj smaller than yj, then it's a concordant pair. Or reversely, then it would be a discordant pair. So this value coefficient is 1 means two ranking lists are the same. If it's -1, that means a ranking list is the reverse of the other one. Yeah, if it's 0, that means two lists are independent. So for the correlation, we can see the highest one is 0A. Talk is highest 0A97. The correlation between PageRank and the number of nations connected. This means that countries connected to more nations have higher impact. Similarly, increasing number of nations connected results in higher social influence in betweenness centrality. Lowest is the betweenness and number of pages, the correlation. So this tells us that not necessarily guarantee the number of pages does not necessarily guarantee a more important information hub. Then we take a look from the clustering point of view. Clustering is mainly applied to find a community structure. The modularity function Q proposed by Newman is equal to the fraction of within community ages minus expected value of this fraction if ages were distributed at random. So the Aij denotes the age weight between vertex I and j. And the Ki is the sum of weights of ages connected to vertex I. Ci is a community which vertex I is assigned. So Aij is actual number of ages between I and j. Kj over 2m is over 2m is the expected number of ages between I and j if it's distributed at random. So delta Cij is 1 if Ci and Cj are equal, belong to the same community. Otherwise, it's 0. So this value of modularity is positive if the number of ages within groups exceeds number expected on the basis of chains. So for a given division of networks in vertex in some modules, modularity reflects the concentration of ages within module compared with random distribution of links between all nodes regardless of modules. However, this modularity function cannot scale up to large scales because it's NP hard. So we in practice we apply the two-phase unsupervised fast algorithm to calculate modularity, which is proposed by Blundell in 2008. It's not only fast, but also it's unsupervised. So that means we don't have to have a predetermined. We don't have to have a predetermined number of clusters. Yeah. So from our results, there are 3 groups and mainly 2 groups: the red dots and also the green dots. The red dots consist of mainly Western nations like United States and UK. and the green dots consisting of Islamic countries which use mainly Arabic language. This phenomenon supports Huntington's argument. Low technology makes world a smaller place. Differences among civilization due to language, culture, and religion are too basic. They cannot be gone soon. The next part I would talk about is subregion identification of pages. Um, in here, I would in this section there are mainly 6 parts. First, I will talk about motivation and problem statement, then the challenges, and then the baseline and advanced algorithm we propose, and the data set and experimental results. For the motivation, um, first, the fine-grained attribute identification will facilitate information precision. This is especially useful for marketing and advertising, and also regional social research. So, what are the challenges when dealing with this fine-grained attribute identification? The problem statement is, how can we accurately identify state labeling of pages in the United States? So for our first thought is, can we just apply majority vote algorithm directly? So in here, we generalize the majority vote algorithm, and we replace and we designated the location of state information. In this scenario, the location labeling is determined by the most votes. So overall, this accuracy is only 59%. So the way we do is randomly select 50% of already known pages as unknown pages. However, this algorithm did work well in page nationality prediction tests with 90% accuracy. So we think about why would this accuracy difference between nationality prediction and also state identification. So the following challenge could contribute to the low accuracy. The different countries may speak distinct languages, but states do not. One public page is less likely to follow another public page which use a different language. However, it's not a case for state. Communication among countries is much less than communication among subdivision regions, which are domestic. The other part is that states in U.S. are much closer to each other and more complex compared to countries because they have shared culture, language, and proximity. So for our baseline algorithm, we utilize the locality of states to find pages belong to their corresponding states. So first, we pick out a set of anchor pages. These anchor pages have local property as multiple seeds, and then we start breadth-first search from these anchor pages. Our target classifier has 51 classes. 50 classes of U.S. states and a class of other regions or other countries, OT. So we define a state distance vector. It's composed of iHop of page and SI and also OHOP. This iHop is denotes the hop distance between page and seed SI. Using inward edge as connection for breadth-first search. For the anchor page selection, basically our algorithm's effectiveness is highly depends on the selection of anchor pages. So the selection is that the anchor pages have to be as local as possible, such that the SDV can provide authentic tendency of a page's locality. So what are the suitable examples of a selection of anchor pages? First, a good example is to focus on those pages focusing on the local communities. For example, the pages of state university or the pages of government, park, or police organizations. What are the ill-suited examples? These are the pages they are popular and thus have global impact, like the NBA team, basketball team public pages like Warriors, or MLB, NFL sports teams pages. Yeah. So in our experiment, we adopt all subsidiary pages of onlyinyourstate.com as a set of anchor pages. It has a distinct page for each state. Each subsidiary page mostly connects local communities. In particular, like for California, because California is much larger than other states in perspective or population and economy. OnlyInYourState.com splits California into Northern and Southern California. So we apply both Northern and Southern California as our anchor pages. So there are 51 anchor pages. Yeah. So the other part is because only in Idaho have been registered, so they use the Idaho only instead for the naming. For the advanced algorithm, we think about what's the drawback of the baseline algorithm. Because a local page can have a few connections with those pages far beyond the state where it resides. Because there may be the middle pages or just have connection somehow with the anchor pages. So this kind of connection noise would highly reduce the prediction accuracy, right? So we define another feature vector as state neighborhood probability. This SNP composed of two parts, INP and ONP. INP denotes the inward neighborhood location probability between this page and the adjacent pages belonging to the region Ri. So it's calculated by the inward edge between this page and region Ri over the sum of all the edges, all the inward edges. So for our advanced algorithm, we utilize both SDV and SNP for feature vectors for ML training and verification. So we utilize both locality and neighborhood context for better allocation identification. For our dataset, we use a dataset of 50 million, which comprise 38.93% out of 38 million pages, which have distinct location information. Detailedly, there are 2.4 million US pages and 12 million non-US pages. And as the figure shows that California accounts for 20% of all US pages and half of all pages, 49% are located in top 5 states: California, New York, Florida, Illinois, and Texas. So we map these cities to corresponding states in which it resides. There are totally 29,000 cities in total in the US. Here is the accuracy summary for our training and verification results. Yeah. So we use 80% for training and 20% for testing. Since number of classes is really large, we use the random forest classifier instead of gradient boosting classifier. Um, for the baseline, we use naive Bayesian, AdaBoost, random forest, and we can see from this summary table that the random forest um, for both for precision recall and also F1 score are at least 20% better than the counterparts of naive Bayesian and also the AdaBoost. So in the following, we just use random forest for the advanced algorithm. Also, we can see that the baseline 69% accuracy is even like 10% better than the majority vote algorithm. Yeah. Also, we can see the advanced algorithm is 89% in precision and 88% in recall and F1 score, which is also 20% better than the baseline. After the summary, we took a detailed look into the accuracy by state. So we can see that the results, advanced algorithm, the better results, over at least 20% better than the baseline counterpart is marked in blue. So we can see that the advanced algorithm beats baseline counterparts in all states, and in addition, many are over 20%. So that means combination of SDV and SMP works. The second page is the other half states. We can see that the class of New York gets worse prediction accuracy, just 48%, and the worst results are shown in bold. California only achieves 50-30% accuracy. These two states account for most public pages. So a page in these two states, it has more higher probability connecting with pages. So it has lower accuracy in a baseline. So we can also see that most states have F1 scores greater than 0.8. Next, we see from another perspective the confusion normalized confusion matrix. So we can see from the normalized confusion matrix, the green squares are the correctly identified class, and in the pink is the first most misidentified grids, and orange are the second, and yellow are third most misidentified grids class. So for the baseline, we can see that many color grids come from the top 30 states: CA, NY, and Florida. These top 30 states, which account for most pages on Facebook, and hence they also have a higher tendency to connect with other pages. So, most misidentified classes are in these 30 states. OT others is another primary source of color grids. With only hop distance considered in a baseline, for a page it's more likely that they have multiple minimal hop distance, so they do not show leaning towards a specific state class. So it's highly probable to be classified as OT. The third finding is that geographically neighboring states could skew identification. For example, like CT Connecticut and Massachusetts MA. For the advanced algorithm, most color grids are come from the top 5 page populous states like CA, NY, FL, Illinois, and Texas. This is a side effect of incorporating neighboring page probability, since these states have more edges, connections, connected with others. So another finding is that in the advanced algorithm, the OT part has fewer lower percentage and also fewer grids. This shows that advanced algorithm is much more effective than baseline. Also, we can see the strong ties outside top 5 pages popular states. Because most yellow and orange grids are smaller than 2%, so we care only about the pink grids outside top 5. This shows the strong ties. For example, like D and PA, Delaware and Pennsylvania, NH and MA, W and NC, and also Wyoming and Colorado. So the next part, I will talk about the global page detection. The motivation is for the global page detection is localization. So, because locality differentiation would facilitate the subtle division of information for different audience. Also, regional analysis in social research would like to remove those pages that are global. The other part is the understanding of location of target audience will highly help the market strategy decision. For example, BMW has distinct advertisement based on elements such as geography, culture, and language. CBS broadcasts different messages to different groups by dividing its viewing audience into separate groups based on geographic data. For our observation, pages, we define those pages as global pages. For the pages that have connection with multiple regions and do not link toward a specific region, so there are two kinds, international and also interstate. So for the math definition, we define it as a page that belongs to page set P, and also it has a sum of delta J greater than n global threshold. The n global threshold is the number of global threshold for global threshold. Delta J is 1 if delta Pj is smaller than minimum of delta Pk plus error. Delta Pk is the summation of distance between page P and class I. So delta J is 0 otherwise. So global pages are those pages which could be classified as multiple regional classes within a small error distance. For the detection flow, for a specific page, first we would test if it's a US page or not. If it's not a US page, then we label it as OT, other countries. If yes, we would put it into the classifier. It could be labeled as local state or labeled as OT. If it's labeled as OT, then we say, oh, it's a global page. So global pages are those within US but have characteristics for international pages similar to pages in other countries. And also, if it's interstate, then it does not link toward a specific state. For the experiment setup, the minimum hop distance of a page we define as m hop is the minimum of I hop and both minimum of I hop and O hop, which is inward direction hop distance and outward hop distance. So the local pages are those with local tendency. They have a number of m hop, minimum hop smaller than the n local threshold. And the others, OT, has global tendency. They have uh, minimum they have a number of minimum hop greater than the global threshold number of they have a minimum hop number greater than the global threshold. So the most common international pages are those closely linked with Middle East contents. For example, we can see on like the left figures is an international page located in New York, and it's highly related to Middle East. One possible reason for these pages originates from the resettlement of Middle East refugees. On the other hand, most common interstate global pages are those commercial oriented. So, for example, the right figure is an interstate page located in Louisiana. It's a Tabasco company. Yeah. So, like, then we take a look from the global page distribution by state. It's 1.16 on average of the global page by state. Not surprisingly, New York has the highest global page ratio, which is around 5%. This result is consistent with our image that NY is a global melting pot. California is the other state whose global page ratio is higher than 2%, which shows its global diversity. We also take a look from a demographics point of view. We rank states by the ratio of global pages number over population density. In this rank, Alaska ranks first. Which manifests its endeavor in travel promotion. And the following are the most popular states like CA, California, New York, and Texas. Finally, I will talk about future work. First, I like to work on the user location attribute prediction. The motivation is that the text-based prediction is easily fooled by malicious users and less vulnerable. So even many previous work have working on this. I like to build a prediction framework based on the digital footprint, and by these features, they are hard to fake, like users' activities on public pages, active time, and also language habits. So challenges are these can be multiple languages. Also, in the same ethnic group, they may have similar behaviors. So the second work future projects, I like to analyze the difference between global pages and local pages. Now, the motivation is that localization is an intrinsic property which affects pages' characteristics. So I would expect that we can explore the community difference between global pages and local pages, and how this distinction would affect various users' characteristics, like a number of comments and reactions, frequency of comments, and also nationality distribution. So the last part I'd like to work on is the adversarial page injection analysis. For example, it's a news like Heart of Texas. It's the most popular Texas secession page on Facebook, but it was found out to be a Russian front. So let's point out the big problem of machine learning algorithms that robotics face. Robotics is sometimes be challenged by these malicious attacks. So the challenges are how do we detect the data manipulation, this kind of data manipulation in different strategy, because different strategy would have different features and characteristics. And also, how do we collect this data for evaluation, because these data are like very precious. So my research schedule, for the first user location prediction, it's just started, so it may take 3 to 6 months. And the analysis on global and versus local, is just 15% in for my progress. So I will take around 3 months to finish it. And the last part, I haven't started, so it may take half a year to one. All right. Until now, I have 3 publications. To working with Dr. Barnett. So I like to thank him for the precious advice. Yeah. Thank you. That's my presentation. Any question?